Thanks everybody for coming to this presentation. Everything is alarming, implementation of alarm management at McClean Lake. Disclaimer, the information is my opinion, expression, standard slide, but this presentation is being videotaped, so I believe it'll be available on the website after the presentation as well. My name is Adrien Rudulier. I'm an electrical engineer with AREVA Resources Canada. I have Darren Walls, who's a technical sales support with Spartan Controls, who is our local business partner up in Canada. Just a brief overview of what AREVA Resources is. We are a leading producer of uranium mining in Canada. We produce about 17 million pounds of uranium a year, and we've been operating in Canada for the last 50 years. We are part of a multinational group called New AREVA Holdings. It's a large nuclear life cycle within France and other places. We operate the McClean Lake Mill, which produces all the uranium from our close competitor, Cameco, from the Cigar Lake mine. And we also employ about 500 people within Saskatchewan. For those who don't know where this is located, so we are here. The headquarters for AREVA Resources Canada is here. The mine is located a little bit further north. And then finally, the North Pole is there. So when people are joking about, oh, it's cold here, there's actually snow, about a foot of snow in Saskatchewan where we're from. So it's kind of a nice break here. We just get rain. So currently, the mine processes about 17% uranium ore. Previously, prior to 2015, we processed on average of 1% ore, and normally around the world it's less than 1%. So our mine mills high-grade ore, which is unique to northern Saskatchewan in Canada. Our mill currently is licensed to produce 24 million pounds of yellowcake a year, and like I said, our concentration or feed grade is anywhere from 0.5 to 30% uranium. So the agenda for this, we're going to talk brief background about alarming at McClean Lake and our problem that we're having. General overview of what an alarm is, where we were, why we were there, and what we're doing now to fix the problem. And just some brief business results achieved in our process. So just give you kind of an analogy here. Imagine you're driving along in your car, rush hour, and all of a sudden something pops up on your XM radio. Oh, favorite song is up. And then you get a pop-up. Oh, my windshield washer's fluid's low. And then finally, I got something blinking in the corner of my eye. Oh, there's a car coming beside me. Now, when you see all those at once when you're driving, what's the consequence of that happening? What's the consequence of you missing your favorite song? What's the consequence of you not having enough windshield washer fluid, or not seeing somebody in your blind spot? Depends on the situation. Usually, you don't care that nothing's going to happen if you miss your favorite song. Maybe if it's snowing, windshield wiper fluid is critical, because then you can't see, snow gets into your windshield. And blind spot detection depends on whether you want to switch lanes or not. So sometimes it might just be blinking a nuisance, and sometimes it might be needed. And you think about time to act. You know, your favorite song probably doesn't matter. Windshield wiper fluid, like I was saying, depends on the situation. You might have days, you might have, oh, I got to get off the highway and get some windshield washer fluid. And then blind spot, that's probably a pretty critical one if you want to switch lanes. And then also the actions that you take. different types of indication will have different actions. So things to think about when you think about alarming is what's the consequence, what's the urgency, the time to act, and what's corrective action. So the background at McClean Lake. So the operator is, our operators are responsible for the safe operations of the circuits. They do some manual control, monitoring, some remote control as well. So our setup at McClean Lake is we have multiple process areas with local operators that control the circuit, and then one supervisor operator that is part in the central control room that monitors everything as more of a backup. And alarming is inherent to all systems, both local and remote, to inform the operators of some sort of problem. Like I said, everybody has a dedicated operator there. So our goal when we were starting alarm management is to provide the operators with a reliable tool to keep them safe and the process safe. And that is still our goal as we go through this, is to give them a proper alarm management alarm system. So like I was saying, when we started this, we had to define operator responsibilities for assigned alarms. You know, we have alarms that are separated by the delta V areas, and when you assign those, it goes to different operators. So we have to define which operator is meant to react to which alarm. So when you have, you know, that border where it's going to multiple operators, who is supposed to react to the alarm? If there's any doubt, then there might be a delay or an alarm missed. So it's critical that you have that definition. And also to have that clearly documented and communicated to the operators so that they know what their core responsibility is. So this is the definition of alarm. It was developed, I believe it's straight from the ISA standard and provided by Exida as the definition. I'll read exactly what it is. An alarm is an audible or visible means of indicating to the operator of an equipment malfunction, process deviation, or abnormal condition that requires an action or a response. That means if something's going off and the operator can't do anything, it's not an alarm. It might be something else, but not an alarm. So the alarm must indicate a problem or unexpected situation with undesirable consequences, not abnormal process condition or expected abnormal or operational event. If there's no consequence of inaction, then it's not an alarm. So in Delta V, alarms will be displayed on your alarm banner or in the alarm list. There's other mechanisms for the other types of messages or alerts that you want to provide the operator. So basic alarm design principles. The information presented should inform and guide the operators to do something. Each configured alarm should be unambiguous and not duplicated by other alarms. For example, you have a tank level, you might have a high and a high. You know, you probably don't need the high. It might be an interlock or something, but you know, unless there's a second action that's required, then you know, it's just one alarm. Yeah, alarms should also explicitly be designed to take into account human limitations. If an operator can't get out there in 5 minutes, then you might have to look at redesigning your alarm. So a typical response time could include troubleshooting alarm, leaving the control room, contacting other personnel, and performing a manual task like shutting off a valve. When you're doing the rationalization, you have to take into account all of this when you're determining how the urgency of the alarm. You know, if you have that tank, it's a small tank that's going to overflow right away, then the operator doesn't have much time to get out there and close that valve. But if there's a big tank, you might have a little bit longer, and it'll help you prioritize alarms that way. So when you're doing alarm priorities, every alarm must have a consequence and a cause. When we were going through this process, you have automatic overriding rules. For us, we have a lot of, so all our safety showers are automatically emergency. For us, we have radiation concerns, so that's automatic. That's automatic emergencies. Anything potentially fatal is also. But you could also have lower alarm priorities that are defaults, like a pump failure, for example. The target alarm distribution also comes from ISA standard. For us, it's 60-80 for low, 10 to 20 for medium, high is 3 to 7. And for them, it's in the ISA standard, it's less than 1% for emergency. But through the automatic overrides, we have actually found that it's closer to 7 in our specific application. So these also the industrial targets. These are based on human limitations. Acceptable is 10 minutes to react to an alarm. Manageable is about 2.5 to 5 minutes for each alarm. Demanding is 1 to 2 minutes per alarm. And unacceptable is like less than a minute for an alarm. I would argue that demanding would also be considered unacceptable or impossible. Just considering, every minute you got an alarm coming in, you gotta figure that out. Where we were, well, when we started this process, one of our circuits was leaching, and our operator was experiencing 60 alarms every 10 minutes. Just imagine you're receiving an email every 10 seconds. Imagine how stressed you'd be trying to keep up with that and respond to that. It's 2,888 alarms in an 8-hour, or emails in an 8-hour day. I couldn't imagine doing that. It's crazy. So yeah, for them, it's 10 seconds to act on each alarm. Why we were there? When we first started the mill, there was no guidelines or specifications for alarms. It was originally built by multiple contractors. They all had their different ideas. A lot of times it was subjective. You'd like, I think that one's critical, so we'll put an alarm there. And the control system's back there, and it was just, it's just software. You just enable it, and it's there. But that creates a big problem for us now, because now we have a lot of alarms, and the operators can't do anything about it. So what happened when we had all those alarms? 60 alarms every 10 minutes. It became white noise to the operators. They couldn't do anything. They would just keep acknowledging every alarm, every 10 seconds, just keep doing that. They pulled out their speakers because, they're just getting like that awful squeal that's coming out of the speakers. There's an alarm, there's a problem, but, it's just a nuisance. Keeps coming in. A lot of the incidents that were discovered they always blame the operators as root cause. It's like, they didn't get it to it in time, but really, is that fair if they have to respond to that many alarms in that short time? So when we saw that, we said enough is enough, and we had to start fixing our alarm system. So the project began in the fall of 2015, and we made some progress, but we're nowhere close to being done. When we first started this initiative, we actually got Delta V Analyze installed on our system. That's a great tool. There's some manual processes to do this, but it's cumbersome. This is a web tool that automatically, continuously calculates your alarm rates and shows you great information. So we use this to assess how bad our alarm system was and to prioritize our rationalization. So once we could prove to management that, this is the problem, we're getting 10,000 alarms or 60 alarms every 10 minutes, that this is a problem. So we contacted Exida. They're experts in this field. They helped us, guided us through developing alarm philosophy, which dictates everything about alarms, what is an alarm, how to prioritize alarms, what to do with all the advanced alarming, delays, set points, and all that, and helped us with that. They also set up our SIL alarm database, which is used for the rationalization process, and provided on-site training and helped facilitate our first rationalization sessions and help us learn how to do this. Like I said, if they weren't part of this, there's no way we'd be where we are today. So the key when we're doing all of this is just that buy-in from management, from everybody in the plant to get this. It was a very difficult process. The commitment from management was actually gained once the first draft of the alarm philosophy was issued. And that's a lot of time needs to be spent on that and getting that all defined, all the roles, responsibilities, your consequence and all that. Just focus on that. And once that is done and the buy-in is completed, then the rest of the rationalization is a lot smoother. So like I was saying, our first attempt, we used SIL alarm as a facilitation tool. We targeted top bad actors throughout the whole mine. And we used Delta V Analyze to figure that out. We did them in week-long sessions. We have a northern mine, so we brought them down to Saskatoon for 5 days, 8-hour days, fed them a lot of coffee and donuts. And then we had a cross-functional team of operations and training. Our maintenance team, our instrumentation, our metallurgy, which are process engineering, safety, environment, radiation, and engineering. You need all these people because they have different views on the process and consequences, and they each bring great experience and knowledge. And the key one is operations. You cannot do this without operations. They're just a wealth of knowledge. But it wasn't very smooth, the first one. Sessions were way too long. 5 days, 8-hour days, it's not good. So we needed shorter, more frequent sessions. Focusing on bad actors seems like a great idea, but it's not. It's awful. You can't get into a groove. You get bogged down. You start doing the bad actor, and then you start talking about it, you want to move on to something similar, and you have already that discussion going, but it's not as bad as the alarm, so you kind of ignore it, and then you have to restart the conversations again and again. As we went through this, we realized that our consequence table wasn't meeting our expectations. Alarms ended up being categorized wrong, or we were having more discussions about is that really the right consequence, severity. And we tried to rationalize every part of the alarm. There's multiple items. There's cause, consequence, operator, response, pretty much alarm help information. Also delays for alarms, set points, and advanced alarming suppression. We found that that's a lot. It's very daunting when we went through the process. So we decided to just scale that back, and we decided just to populate the cause, consequence, and corrective action. So what we do now is our first pass is limited to just what is an alarm. Step through each configured alarm in the mill by mill area. We have a total of 12,000 alarms. Keep doing the cross-functional team. And we do monthly sessions now at the site in 2 days, 12-hour days. And we can get through about 300 alarms a day, which is a lot better. By the end of the second, or it's a 3-day up there, so the second day you were kind of starting to get burnt out. So this is a perfect time frame that we found that worked for us. And also, it puts less of a
strain on the already thin resources at site, because you're pulling operators off the floor and instrument techs off the floor as well to fix things. It's like, so our rationalization team hasn't changed since the beginning, and we have also had about 34 participants to date. We generally swap out a couple people per session, so that we still have that core knowledge being transferred, and we're not starting from scratch every time, and people can learn as we go. So our process is what we do is, first thing is we identify the consequence of no action. So if the operator ignores this alarm, what's a reasonable consequence that's going to happen? We determine what the consequences are for safety, health, environment, and operations. Then we determine the operator urgency. In the alarm philosophy, there's some more detailed definition of the consequences, but essentially you go through that and decide how severe a consequence is. In this case, it's fairly high as a moderate, and then the operator urgency. And then with that, it automatically determines, based off your matrix, what the priority is. So there's no longer it's you going there, I think that's a high alarm, and then you just set it as high. It's repeatable, and it's consensus, and whatever happens to be, it is. And then you also do that secondary check of like, does that really make sense? And then you kind of look back, but we try to limit overriding the priority level, because this helps us get into those targets, those ISA targets for alarms. One thing we also do is review the set points. If there's any time that we think alarm needs a delay or a dead band, we talk about it briefly, and then we use historical data that we bring up during the sessions to take a look at it as well. And then if there's a need for advanced or conditional alarming, we just identify it, mark it down, and then when we do a second pass, we'll pick those up and determine that in the future. Because again, for conditional alarming, when you have so many unrationalized alarms and you don't know if you still have nuisance, then it's hard to figure out what you want to suppress when everything's alarming. So like I touched on, the alarm philosophy has a lot of great information in there, a lot of good practices. The end goal is to implement everything within the alarm philosophy, but we found it wasn't practical to populate all the fields during the first pass. It's very daunting. Like I said, we focus on what is an alarm and what is not. And we have potential to revisit the first pass to populate the alarm help and also do advanced alarming. So what we have done to date, first changes were implemented in November of last year. We've roughly done half the alarms. We're expecting to finish the first pass by the end of next year. So that's a very large time commitment to do this. It's a continuous process. You always have to go back and check to make sure that what you've changed actually worked. And once we actually do that, implement the changes, we can actually figure out what actually is a nuisance alarm, or based off of an actual equipment malfunction, or maybe something actually needs to be redesigned. So you can actually find the bad actors quite easily. For implementation, we typically send out the changes about 2 weeks after we do the rationalization. We don't wait for a complete area to be done. To do a mass rollout, we do things incrementally, and we can see changes right away. And the changes are done by our instrumentation group. They're the keepers of our Delta V system, and they just pick away at it as they can when they have time. So after we do the rationalization, we do the monitoring step using, again, delta V analyze. It's one of the key tools. We identify the top bad actors, issue new set of changes to site to fix those. Rationalization doesn't fix all alarms. It's an iterative process, takes time, and you can pick out the penguin out of there. So our path forward later on, like I've said again, complete the first pass for next year. It's to get the high priority alarms complete, drive down those alarm rates, let the operators control the process and being able to react to the alarms as they can. Also implement the conditional alarming, advanced alarming, flood suppression. We get a lot of power outages at site, so the operators don't need to know that. You have hundreds of alarms coming in on a power outage event, but it's hard to do it now because there's so many alarms, and some might be critical and some might not be. So that's another step. And we're thinking of potentially doing alarm help with a smaller focus group of operations and some other technical folks. But that's a key one. That's a lot higher on the list because I believe alarm help is a great tool for operators, and it just takes time and resources to populate that information. So what we've seen, I was talking about the leaching operator. So in October of last year, they were receiving 17,000 alarms a day and about 120 alarms per 10 minutes. That's a lot. And the target is less than 144, so we were way off. For alarms per 10 minute, acceptable, like we're saying, was 0 to 1. We were 120. After rationalization, we actually got them down to 240, which is still not quite target, but still okay. And then the alarm rate is still manageable. We reduced the number of alarms by 98%. Not saying that we just deleted alarms, but a lot of the alarms were duplicates or didn't provide the operators the right information to diagnose an issue. A lot of them, we had flow for reagent and then our measurement within the tank. So the feedback we got from operations is that they can actually operate the plant. I'm not quite sure if they plugged the speakers back into the operator stations yet, but they've really noticed the change, and getting that feedback from the first session. Now operations is for sure on board with this initiative, and they see the value to continue this. And it is a long process. It doesn't get done overnight, so it's continuous. And they look forward to the monitoring reports every month to see how well we're doing with reducing our alarm numbers. So, like I was saying, buy-in, ownership, the change in culture, you hear it in the other presentations, and that's key. You can't do this alone. You need help from everybody. And just to get that change in mentality, you change how you operate the plant. You have different expectations. You don't say, oh, I'm just going to ignore every alarm. You say, I'm just going to reduce the alarm so I can actually operate the plant. It's continuous improvement. We're not stuck in this is how we're going to do it for the end of time. You tweak things as you go, and like everything, you always improve on your process. So the plan is to keep this going as a project, and then once we get to a point where we can hand it off to site, and then they can run with it. Once it's not such an onerous task of the large volume of alarms, it'll be more of like the monitoring reports. You keep, every month you just go through the top actors, and it might take a couple hours a month to go through this instead of 3 days a month. So the take-home message, alarms must call for an action to avoid undesirable consequence. Anything not meeting this criteria is not an alarm. It might be something else, but it's not an alarm. It takes commitment, like saying 3 years to do the first pass. Then we're going to go through it again and again and again. You just develop that culture of wanting to reduce your alarms. And when we do new systems, we go through this process. Even now, we have small controls changes, and we got that group on site to think about this. And they actually go through this process to help us out so that we're not re-rationalizing the system after it's done and after we do the first pass. So it's that continuous improvement, organizational commitment, and actually focusing on alarms. Any questions?
I have a question. Appreciate what you brought in. It's good stuff. How do you see best making this sustainable so that if we were to visit a year from now, it would be an improved state versus current state?
Okay. Yeah. So the question was, how do you make this sustainable? It's that culture change and getting the buy-in from site to take ownership of this initiative and doing that monthly check. And our management from the top is focused on this to keep this going. And you'll see that everywhere. It's just you need the buy-in from management and trickle down and see the changes. And we have seen positive results on this, so people across the site are committed to this. And so that's the only way you're going to have that is the commitment and ownership.
We did alarm rationalization a couple of years ago. We had a lot of what I call engineer alarms, where an engineer thought it was a good idea for an alarm that meant absolutely nothing to the operator.
Mm-hmm.
We had roughly a 15% reduction for alarm rationalization. What sort of reduction in alarms do you guys have as far as this doesn't qualify as an alarm, so it's off the list?
Yeah. So what was the question there?
Do you have out of the 5,500 alarms that you've done so far, what sort of percent are not considered alarms anymore, or are there any?
So yeah, the question was what's the percentage that become non-alarms? I'd say close to 30 to 40, but they don't go away. They become alerts, which if they're bad process variable or equipment malfunction, it goes straight to the maintenance group. And so they have an alert list that they monitor to take care of those engineer alarms. So.
Yeah, great stuff. Thank you for the share. On the ability to be analyzed, did you use it at the very beginning of the process to identify the bad actors, to identify what really is happening, and to help you with the KPIs before you actually go ahead and put the program in place?
Yeah, so the question was, did we use Delta V Analyze from the beginning? And yes, we did. That was the first thing we did was we grabbed that, collected data for a month or two, and then we used that as our benchmark. And we used that to justify that to management, to show them that this is how bad we are. And then we actually use that tool as our continuous monitoring. So we every month we use Delta V Analyze to take a look at the top bad actors. And at that point, after it's rationalized, they're true bad actors, and not just those fleeting nuisance alarms that aren't actually alarms. So we take care of those monthly. Yeah.
Did you see any changes, or did you need to make any improvements on extending or stale alarms?
The question is, do we have to make changes to standing or stale alarms?
Well, I mean, you talk a lot about rates, but there's also, you need less than stale alarms on your standing alarm list.
Mm-hmm.
Was that ever an issue, or was it just rates that you were?
So we had so many alarms that we couldn't find those.
Okay.
Like 17,000 alarms a day. They just kept going in. You sit by the central control room and you can't tell what's actually going on. So they just ignore all that. So I'm sure that when we're done the first pass, we'll be able to see what's standing or still there.
So every alarm requires a response, a documented response. So when you're doing a rationalization, did you have an area, some companies actually have an alarms, which gives you, not a lot of time to do each alarm. So did you actually document what the response should be from the operator for each alarm?
The question was that did we document what the operator response was? And the answer is at the start we did, and that goes into more of the alarm help information. But then we ended up not documenting that when we did the rationalization. We talk about it, but it's for us it was an onerous task to do that all at once because it just bogged down the sessions to document all of that. So we didn't do that. So.
If you bring on an alarm, but you don't tell the operator what you're supposed to do, then to be quite honest, I don't see the value of the alarm anyway. Unless you just rely on the operator that, hey, this guy's been here for 10 years, he knows what to do. This guy's been here for 1 year, he doesn't know what to do.
Well, if you document it in the SIL alarm information, it's not really going to help operators in the field unless you populate all of the alarm help. So, like I was saying, there's so many alarms that it would take years to do this, and we just didn't have that time. But we do have standard operating procedures, and the operators are trained, and they should know what to do on an alarm.
How are your instrumentation folks moving this information from SIL alarm, the software they're using for rationalization, into the Delta V software? Are they manually doing it, typing it in, or are they exporting files?
Yeah, so the question was how our instrument techs are implementing the alarm changes. So SIL alarm does have a export, direct export using bulk edit for the alarm changes. We decided not to go that way. We have some custom alarms, and so what we do is we do kind of an import, export, compare on the SIL alarm database from a previous version, which dumps it to Excel. And then we send a line-by-line property change. And since we don't do a lot of changes per alarm, it's more of priority changes or set point and delays. So it's not that much information to the instrument techs. And then we send them in PDF or Excel format, and then they just cross off each line, and they do it manually.
Because when you guys do alarm help, it'll be a lot more work.
Yeah, so that would be a straight import. That's
That they'll definitely use bulk edit for that to export that information out of SIL alarm.
Yeah, but like saying, we have some custom alarms for force and simulates that we just decided off the bat that we wouldn't use that SIL alarm tool.
Guys, I just want to add a point. Can everyone buy the session using the mobile app? This one actually has that feature enabled before you leave. Sometimes they give it away.
How do you get your first list of alarms? Like, you get 12,000 alarms.
So the question is, how do we get the first list of alarms? Exida actually populated that database for us using bulk edit, export feature from Delta V and import straight into SIL alarm.
SIL alarm actually gave us, or Exida actually gave us the templates to export all those alarms out into bulk edit in Delta V. So if you're,
Without bulk edit, just go right in and just export it.
yeah, they just gave us the templates. Then that's what we use to bring the information into the SIL alarm database.
And you just go through each one inside. So
Yeah, the tool, there's filter tools, so you can actually isolate a subset of alarms that you want to work on. And you actually can select up to 5 alarms to do at once. And you go through, it guides you through the process. You just, every page has different information to enter. And then once you're done, it changes it and you just save it. And yeah, it's a great tool to help with facilitation. It'd be very cumbersome without it, to be honest.
Yeah, I think one of the key messages is using SIL alarm. That becomes your master alarm database, and your culture has to be that that's part of your management and change process, that no alarms get changed unless they go through SIL alarm. That's a key message.
Have you been able to consider at all what you might do in a new construction to not get into this place?
So yeah, so the question was, have we considered what to do for new construction? We were doing it already, not for like a large greenfield, but because we're not doing that at this point, but more of the small change controls. They go through the same process that we do. They figure out what's the consequence of no action, the severity of the consequence, and the time to respond, and then they automatically assigns the priority. So it's based off that alarm philosophy, and it's that change. We have yet to do a full greenfield site. That'd be interesting to see how accurate it is if you don't have that historical data, but you rely on the expertise of the designers for that.
So it's the designers then who had identified the alarms initially for you?
Yes, and I'm sure that you'd go through, after you operate the plant for a bit, you get some knowledge and revisit that again. So.
Did you do anything for alarm floods? You know, one alarm triggers another 20 coming after it to mask those out?
Yeah, so this question was, did we do anything for alarm floods? Just on the sheer volume of it, we couldn't identify what the floods are. And so after this first pass, we'll get some more information from that Delta V Analyze tool to figure out what an actual flood is and see those events. So that'll be part of our second step, is to identify those and suppress alarms when there's a flood.
And I don't know if you've seen those new module templates that are built for handling alarm floods. They're actually pretty slick to use, so.
A lot of like removing redundancy with the alarms too, right? Like if you have an interlock kicking off a pump, you don't need all of those different devices sending you an alarm because your alarm already should bring you to that pump and you can see what interlock actually kicked it out. So in a way, just removing the redundancy and making interlocks a little easier rather than alarm on a piece of equipment and then that equipment failing is your initial alarm.
Okay. Well, thank you guys for attending, and enjoy the rest of the conference.